sketches where KPN was in, but this year we made it actually. We have connected them. This is the link going to Felten's longest link, 35 kilometers. It's outside of Berlin, where the core routers are put. Then we use a dark fiber connection from Versatel getting to a foundry, and then both Juniper boxes terminating the sessions. So in-house network is then connected from these points. You can say that all the networking, what's not inside this picture, is that the force 10 is also connected to the foundry box. Okay, and it looks like this. When you look at the top, the blue boxes, this is Juniper, this is two M7i boxes. In between, there's a buffer. This is a Cisco switch, mainly used for, not disturbing the foundry box. No, it's not a physical firewall. It's some kind of, we have the management VLANs on. Force 10 box is a black one with a lot of fiber optic cables in front of the box itself, so that you can hardly see it. And down there we have a Force 10 box in Ether-scale architecture, which terminates the Versatel BGP sessions. So, as said before, we have some kind of a problem. If you look at the different bandwidths, 10 gig, 1 gig, 100 megabit uplinks, if you have such a mixture of bandwidths, you have to do a little bit of traffic engineering.
So, anybody ever heard about traffic engineering and what this is? Not so many people. Okay, I'll just give you a short introduction. Traffic engineering means that you set certain preferences, what route should be taken into account. Because if you have several providers giving you a full routing table of the whole internet, it's not so easy to find out which is the best way. Because BGP is a path vector protocol. That means a route is selected on its length. If a route gets through, let's say, 10 providers, and you have another route to the same destination, having just 2 providers in between, the route with the 2 providers in between is selected. But sometimes this link is not faster than the other one. And so we need to decide what is better. And we got a strategy this time that we do the balancing via setting a local preference at our outbound routers. And we said, hey, if the IP is directly connected to our peers, this is definitely the best way. And so they get the highest local preference. If it's a direct peer of one of our peers, we assign them a medium preference of 200. But Versatel has a very big link of 10 gigabits, and so their direct peers get a preference of 300. So they are preferred. And then there are some special paths. We know that they are pretty good. Like in Berlin, dehosting directly connects via B6 to DFN and some other Berlin providers, and so we prefer the path getting in via dehosting. We prefer them over any other route like the ones we got from KPN or stuff like this. And the local preference, of course, is only for the outbound traffic. But we want also to engineer a little bit about the inbound traffic. But engineering inbound traffic is, let's say, way more difficult because, of course, it's a distance vector protocol. And the only way you can do stuff like this is by announcing your own autonomous system number, let's say, twice. And so the path gets longer to this provider. And so this is the way how you select the inbound traffic. I'll show you. Probably some of you saw this site. I show you. Oops, so. Nicht so wichtig. Okay, this is how it works. See, this is the traffic for the different uplink providers. Here you can see this is Versatel, and it gets about 500 megabits of outbound traffic and not so much inbound traffic. Although KPN gets a lot of inbound traffic, but let's say only 100 megabits of outbound traffic. Telia gets, let's say, the same in and outbound bandwidth. And Cogent is also selected for outbound traffic. This is and the inbound traffic gets less because we prepended our network twice, as I said before. And so this path gets, let's say, a little worse than the path than Telia and all the others. Finally, we got dehosting. Dehosting gets the Berlin traffic, and so you can see it has a lot of in- and outbound traffic. As we mentioned in the first slides, we also have IPv6, and so we have several IPv6 peerings. We got traffic from KPN, Freenet, and dehosting. And as you see, the IPv6 traffic is not so much than the IPv4 traffic. So next time, also use IPv6. Okay, then let's get to the wireless LAN. I think the wireless LAN is better, and we can just say it worked. Not perfect, but it worked. And so, I think we should get someone a special applause, because it's Mac who took a lot of effort into building the wireless LAN. Okay, let's get to the technical details. This year we got a complete solution from Aruba Networks. And this is a kind of centralized VLAN switching architecture with an intelligent controller to the access points. This equipment actually worked at the hacker conferences in the United States, namely DEF CON and Black Hat, for the ABG. And here it worked also. The idea of this centralized wireless LAN switching is that it does active defense and detection of rogue and fake access points. It detects man-in-the-middle attacks and fights ad hoc networks. Yeah, and the special features of this hardware is, as you can see in the map, you can see actually the transmit power for different, the calculated transmit power for different areas of the building. You have this nice a planning tool where you can put in a map of the building and you sketch into the access points, and of course you have to calibrate it, and then it gets you these heat maps. This is pretty cool for triangulating roach access points, but as you know, when triangulation works for access points, it works also for users, and so it's not probably perfect, okay? The conclusion is it works, and we had a daylight average of about 350 users, 130 at the night, and the user peak was 509.
There's something funny I want to say about the rogue access point detection.
Come on, Rob.
The Freifunc people were actually firing up access points every once in a while, and while they were flashing them, they couldn't prevent them from going to certain channels like channel 1 or channel 11, depending on the access point. And we got to the point where it was so well calibrated that I could actually tell which side of the table it was on from this graph, and we could actually call the people up and say, you have a rogue access point again. And it got to the point where it got scary. It's like,
Okay, then let's present some statistics. We had actually 2,342 network ports. That's no joke. We had 40 separated virtual LANs, VLANs, and of course we had 40 subnets. These were subnets with prefixes of /20 or /24. This one is just an example of one of the traffic graphs from the 10 gigabit link from A to D. And you see, it's a reasonable amount of traffic. As we published before, you can see all the detailed stats at the management side. The URL is at the bottom, if you're interested in. For uplink traffic, we got an average of about 802 megabits out and about 230 megabits inbound. This is a huge amount. It sums up to a cumulated traffic of about 40 terabytes outbound traffic in 4 days and about 10 terabytes inbound traffic. The peak, the 5-minute peak of our uplink was about 1.3 gigabits, which is a lot. I showed you before the traffic distribution to the different peers. These are also on the network. You can access them through the URL down at the bottom. Of course, we had some anomalies, because in no case this works just perfect when you build up a network. And we had a lot of fun analyzing the channeling and trunking of, or in Linux it's called bonding, of different Ethernet devices. So you take 2 gigabit devices and you form a trunk, and then you have a virtual bandwidth of 2 gigabit over this link. And there were some negotiation problems between different devices from HP and some other vendors. Also, we had we found out about Mac aging time bug in the big HPs, which actually opened the case at Hewlett-Packard. And today, some people from United States and France phoned us just to verify what happened and to get more details. So the guys at HP working on a solution for this problem. On the first day, the forwarding engine of one of our upstream routers died. This routing engine was just rebooting, and it was not working anymore. But we had a spare Juniper router, and so we can just plug in the other one. And so it worked. We also had some denial of service attacks, but they were a lot less than last year. So probably the... yeah. And maybe the hacker FX hotline worked this year. Maybe someone used it. I don't know. There were also some very funny defacements we saw, and we actually got some abuse calls, but I think there were less than 5 abuse calls, and so this is no problem. And of course, we had many roach access points, but it was a lot of fun to localize them and to shut them down. Remotely shutting down, because you can do some de-auth attacks and stuff like this on these access points to shut them down. But this is just for ensuring that your wireless LAN works, and so. Okay.
So I have a quick look to the next year. What hardware to use, bigger step back, same building on new wireless LAN and wired LAN. So much uplink, less effort. You see all these signs, use more bandwidth. And I think it's not a joke, we have a very potential sponsors here, and they like to see traffic on their network. So we proved this year that we can build a network, a running network, which is capable of pushing gigabits of traffic. And if you have some nice projects for the next year, I've talked to the sponsors this year. They will supply us with the same equipment. Next year, we will also get all the uplinks we have this year. We will get the next year too. So there will be another 10 gigabit link next year. There were some questions if you have 1.320 gigabit of traffic on the uplink itself, why to use 10 gigabit? It's a problem that in former times in SDH technology you normally have steps like 622 megabits, then 2.5. They're smaller the steps. If you use 2 gigabit as traffic outside, there's only one step you can do, 1 gigabit, 10 gigabit. Because fiber optics in going to the building are limited, and therefore, even if 10 gigabits looks a lot of traffic you can use, if you have 1.5, it's important to have these 500 megabits more, and therefore we decided to use 10 gig next year too. Same building, a new one. There's some rumors saying that maybe the building is too small or too big, and as far as I heard, there's no new decision, and that I would be delighted to be here in BCC again, because the infrastructure is well under control of these 16 people working for you, and therefore it would be a pleasure to see you all here again, and not in a different place where we have a lot of new equipment there and new cabling, and maybe also a lot of new problems. Yeah, wired wireless network. I think we cannot top it next year. We will not have 10 gigabit ports in the C, D, A, and D level. But maybe if somebody has